Not tonight, kind of a small meetup, dreary weather, in case somebody wanted to make the trek out here. But today we're going to talk about SQL Viking, a tool that I've been working on for a little while now. Actually just finished refactoring it like 2 hours ago. It wasn't working when I woke up this morning, tale of my life. A little bit about myself. I graduated from JMU with a BS in CS in 2012. Cut my teeth doing AppSec over at the DoD, working mostly on a .NET-centric stack. But recently transitioned over to Invisium and started working on the commercial side of the house. And I've been there for 2 weeks and I'm already getting exposed to a ton more technologies. So I'm really excited to start tearing into a lot of different things instead of working in such a static environment. So I guess, what you guys are wondering, what's a SQL Viking? SQL Viking is a post-exploitation tool that takes advantage of unencrypted database connections between a client and a database server. Why pwn the database when you can just pwn the connection? Anything and everything you could ever want is already flying over the wire anyway. I don't need to bother using SQLi or exploiting your database itself. Everything's there for the taking if I'm already on your network. Web servers with the assumption that an attacker is not going to be on your network anyway. I don't know how that's a valid assumption or a good reasoning, but that's what they told me.
So for the legacy crunchy exterior,
Yeah, exactly. Right. So you can, this is a simple Wireshark PCAP. You can see the request query here. Down in the corner, you can see the query itself. The select version. Add version is just a variable that stores the version number, and you get the response. Ubuntu. The actual number itself, I think, is encoded, so you can actually see the ASCII version of it. Yeah, so I saw that sitting on the wire. I was like, wow, this is a problem. So let's take advantage of it. So the overall structure, it runs on 2.7.x, and that's because it leverages the SCAPI library for packet captures. SCAPI has not been ported successfully to 3 yet, so kind of stuck using Python 2 for the time being, as long as I'm using SCAPI. But it's kind of broken up into 2 pieces, Scout and Pillage. Scout is the passive piece, which is it's passive, it's extremely unintrusive. There's no way for you to really detect it's on your network other than finding the actual executable itself running. Pillage, on the other hand, is all the way at the other end of the spectrum. It's extremely powerful, but is also extremely noisy. People are going to see you in a heartbeat. Anybody with a half-decent IDS team or application logging or anything like that is going to notice you very quickly. But I also built it with extensibility in mind. So I really tried to separate out the core logic that handles all of the storing and logging of data and the packet capture piece away from the piece that actually parses the data that gets pulled off the wire. So adding support for new databases is actually very simple. You just extend a base DB class, implement a couple of methods, and as long as you return the data in the correct format, you don't have to worry about tinkering with the core logic at all. You just pipe it right back there, and it'll do all the storing and all the logging for you, which I try to do to encourage people to help contribute to the project. So using it's very simple. Python SQL Viking -C, pointing to config file. Config file has a couple of settings. It's on the next slide, I'll show you. But it does a couple of things. Like you can specify target databases ahead of time. As a penetration tester, the first step you do is go through and enumerate everything. So you're probably going to be aware of a lot of these databases beforehand. So you can put it in there so SQL Viking knows ahead of time exactly what traffic it's supposed to be looking at. You can preload queries to run via Pillage. We'll go over exactly what that means when we get to the Pillage piece. Tells it how to handle all the data logging, such as auto dump everything it's found every hour to a file. That way you're not blowing up your memory, hosting everything in these big ass arrays. But a lot of this functionality can also be modified during runtime via a very hacked together menu that it's got. So just a quick shot of the config file, broken up into a couple sections. Very standard layout, # for comments. Everything's separated out in a couple sections. Here's what the UI looks like. At the top, it keeps track of the number of DBs it currently knows about. The reason that's a live number and not static is because there is a fingerprint mode, which will actually start capturing all traffic and attempt to try and fingerprint it as a database type. Turns out that's very difficult to do. So still working on that piece specifically just for MySQL, let alone the host of other databases that are out there. Keeps track of the number of connections. Number of connections are just the number of open TCP connections existing between a client and the server that it's currently tracking on. And then number of queries number of queries captured. So how many packets is captured thus far. And then from there, you can add a new DB to track if you come across something while it's already running. You can specify a new query to inject with Pillage. You can manually dump everything to a file that you've had so far, and then quit. So again, broken up into two pieces, Scout and Pillage. So the first one, Scout. Got this awesome picture. Yes, that is a Viking riding a unicorn in space on a rainbow with an AK. You see that correctly.
And red sneakers.
And lighting.
Oh, and then sneakers. I haven't even seen that before. Yep. Fantastic. So this is pretty much, the best part of this talk, I have to say. So Scout. Essentially what it does, sits on the wire, pulls all the traffic off, and it'll track a bunch of information for you. Initially, I went really overboard in trying to build Scout features in, such as building out entire schemas by keeping track of table names, column attributes, pretty much everything you could know about a database, and realize a lot of the information is not useful to a penetration tester. And after all, this tool is a penetration testing tool, or I should say, post-exploitation tool. The hacker is not really going to care if this column cannot be null. I mean, it's not really very useful information to him. So I kind of stepped back, and right now, all it tracks is schemas, or instances as I call them. My SQL calls them schemas, as well as any associated tables and columns part of those tables.
Is this where you're also fingerprinting the database?
Yeah, that would happen during Scout as well. That would happen in that piece. It also has the ability to go ahead.
So when you say you pull traffic off the wire, what are the kind of constraints on that? Really, if you just put a machine, it's one thing you tap a machine onto a switch, and then you can, do a mirror port or something like that. But from, pen testing perspective, what's the best way to get in, and then also get in the right place to
exactly
the traffic?
And that's really the biggest limitation, and why I call it a post-exploitation tool, because this isn't going to help you when you're outside the network. This is after you're already inside. You're wedged deep all the way back into whatever subnet has your databases. Or actually, that's not true. You could be on the DMZ as well with the public web servers, because that'll be receiving the traffic as well. But again, you're very limited. As Ping mentioned, if you're on a switched network, you're not going to be able to see much unless you manage to physically hook into a span port. So how useful this is, I don't know. It's a fun project, though, and I really enjoyed writing it.
Well, it could be, for insider, attack, for example, your system admin is not supposed to be able to see credit card number, for example, right? But
exactly.
If you have a way to access the switch, for example, then you may just get all the dump of the,
right.
yeah.
Yep.
So that would be an attack.
Yeah, if you're, go ahead.
It would seem to me that it's still pretty good if your first point of egress is going to be on the web server of the DMZ. Normally it's talking through the firewall, but as long as you can go ahead and monitor the outbound traffic right there, maybe you're on that port.
Exactly.
And actually that's going to be more stealthy in some respects because you can monitor the in and out on that server.
Yep, so it's got its uses. Not the perfect tool by any means, but it has its place. So on top of tracking schema, it'll also track any credentials it pulls off the wire when during a login sequence. So it'll pull usernames, password hashes, salts. It also has the ability to track the authentication scheme. MySQL, again, for instance, because I use MySQL a lot because that's the one database I've worked with this tool a lot with so far. MySQL has 3 different authentication schemes, and that really changes the way that the password is encoded, or hashed, I should say, before it's put on the wire. So if you want to take that hash and attack it, you have to know exactly what they did with it beforehand. And then, of course, it pulls queries and the results, correlates them together as well. I mean, that's the big crux of it. All this functionality as well, when you're implementing a new database, you don't have to have support for any of this if you don't want. You could implement just the parse request, parse response method, and if you wanted to, you could just take the data, encode it, or find every valid ASCII character, return that, and then it's human readable. At the very least, you'd be able to see the queries that are being run, assuming it's not encoding it in some weird way before it puts it on the wire. But at a very low level, you could do that. But if you wanted to, you can also add support for these functions by simply calling a couple methods. On the connection object, you just call con.founduser. pipe it to that, and then the actual connection object in the background. The logic you don't have to touch will handle storing that for you. It'll make sure you haven't found it already or not storing multiples of the same username. So it handles all that back-end stuff for you. But it's completely optional to implement. Demo time. So I'm actually going to run this from my desktop to make it just a hair bigger.
So just a quick thought. Do you do inline analysis, or you dump the data aside and then so you can plug in various modules to do analysis?
So right now it's multi-threaded.
Okay.
So the piece that's actually, this piece that's running SCAPI and pulling stuff off the wire is its own thread. The only thing it does is it pulls things off to a wire, pushes it off to a queue, which in Python is a thread-safe array. Pushes it off to a queue and then just does that. It just pulls as many things off the wire as it can, and then a separate thread handles the actual parsing and interpretation of the data. With the thought that as long as SCAPI doesn't get backlogged, you can keep pulling stuff off the wire, and the actual thread that handles all the parsing can get backlogged. It can be several seconds behind, but it's not really going to matter. Eventually, it's going to get to it. Or if you have it all in the same thread, if you're taking a long time to parse through this data, you're going to start missing packets, and that's when you're really going to start having problems. But yeah, very good question. So, quick demo. I don't know. Can you guys read this? It's kind of small. Yes. No. Okay. Well, on the left side here, we have the actual menu for the tool. I already went over this, so it doesn't matter. And on the right side, we have the command line client hooking into a MySQL database. As you can see, as I'm running these queries here, use testdb, use MySQL, select that version. This queries captured number is skyrocketing. And that's because a lot of these queries are run in the background. Like when you switch databases, or switch instances of a database, it runs a ton of queries that you don't really see. But we're just going to write it to an output file, see everything it captured. And you can see right at the top, we've got the root, the username that I logged in with, and this array right here, which is empty right now because I haven't implemented this, would also store the password hash, the SALT, and the authentication handshake scheme that was used. The two instances it found below, testdb and MySQL, are the two that I logged into. And then you start seeing the actual queries I got run with the timestamp they were executed at. So this is actually the handshake that happened here. I'm just dumping that to the file, not really doing anything with it. Switched instance to testdb. We actually switched it. The show database request with the 4 databases, I keep saying that, the 4 instances that are actually in that database. So these queries here, again, this is functionality I haven't completely built in yet. This is actually run when you switch a database. It runs a show column or show tables method. It'll come back and tell you all the information about your column, all the information about your table, including all the columns in it and the details about it. But that's broken right now. I haven't fixed that yet. Keep going down. We'll see some better stuff. Switch back up to MySQL, runs all the same stuff again, show databases, show tables, and then show each individual table, and the same protocol error, expecting EUF error.
So are this kind of analysis result of each package that's coming along? Or
Yep.
Okay.
Yep, that's each packet that it gets, well, I should say, it's not each packet, it's each query and response. As you'll actually see here, the select star from testdb.customer login comes back with a ton of data, and it doesn't come back in one packet. It comes back in like 30. So it actually does have support for frag packets. It handles them just fine. You can see, so the very first line you have the actual column information, email, customer number, password, question ID, and answer. And then below you have each row in that table. And there's a lot. There's like 120 or so different rows. So that's not all from one packet. That's across several.
So if there are multiple clients querying, can you correlate those requests and response?
Yep. So let me scroll back a little bit. Oops. So it tracks, when you're outputting stuff, it tracks by the specific database itself, by the port and IP. But when it's actually going through and parsing the information itself, it tracks by TCP connection. So if you have 2 clients connecting to the same database, the report will spit out They're not going to be, they'll be out of order. They'll be the order that they picked them off the wire, but they will be correctly correlated because it tracks by TCP connection itself, or by individual TCP connection. So you're not going to have like client 1's request correlated with the client 2's response because they just happen to
represented by a similar demarc as what you have there for the IP, having some kind of separation for each of the different.
If it was connected to a separate database, yeah, or on a different port, then you'd have it broken out and you'd have everything down in a new section. This is just the human readable one. I figured I should implement this one first since it's best for demoing purposes. But I do plan on putting in JSON and CSV support as well, which will be a lot better if you want to start piping this into some other, into something else or import it into something else, whatever you want to do with it really. But for right now, I just made it so you can dump it and make it human readable.
Another thing you could consider is to use SQLite database. It's a quick file and you can dump the data in some
That's a very good
structure,
point.
right? And then so you can do query on SQLite database, very simple.
I like that idea. I may have to. Okay, I'm gonna steal that if you don't mind. Using SQLite would actually solve a lot of the memory issues too, instead of just storing stuff in flat files as well.
I actually work on a similar project for basically a protocol-based analysis, and we dump the packages into a NoSQL database.
Okay.
Because it's almost like time series data.
Yeah.
So we dump in there and stream the analysis through the data.
Mm-hmm. When I had first started, I had actually looked into using Cassandra, which sadly is no longer free, but is freaking fast. It was one of the fastest databases around by far. I don't know what it is these days. That was a couple months ago. But yeah, that's a Scout tool in a nutshell. Basically, that's what it does. Again, just MySQL for the time being. You still good, Pat? Okay. Next up, Pillage. That is us, SQL Viking riding a horse, and that's our database that doesn't know what hit him lying on the ground. Pillage. This is, in my opinion, where the real fun begins. Pulling stuff off the wire and storing it. There's really nothing sexy about that. Really nothing. It's kind of cool. It's got its uses. Pillage, on the other hand, lets you execute arbitrary queries against a database without credentials. That's freaking awesome, in my opinion. Now I'm on your network. I don't have any credentials or anything, but now I'm executing commands. So if you got your web application using SA or root to hook into your database, and I start running execute command shell, I can go from just sitting on your wire with no privilege to backdoor on your database server and a couple of keystrokes. But the way Pillage works is it leverages TCP injection to inject new packets into an open TCP stream. It's extremely intrusive, very, very intrusive, and is guaranteed to break the TCP connection. I'll go over why in a second. How this actually pans out in terms of what happens in a live environment varies very widely. In the demo for this, I'll show you how the OSX MySQL client freaks out and sends like 100,000 packets, and you have to kill it because it doesn't know what to do. The Windows one, on the other hand, I can't remember if it was MySQL or SQL Server, one of them, but it just sees the bad packet, it sends a fin, closes out the connection, you just have to relog in. Handles it very gracefully. So you can be at either end of the spectrum. There's really no way for you to know how it's going to work. This becomes even worse when you have actual web servers trying to handle these packets it doesn't know what to do with. And it's really going to vary very widely in terms of the application's going to crash or if it's just going to relog in with the creds it already has. So very powerful technique, very dangerous at the same time, very noisy.
So just quick question, conceptually, why doesn't the database authentication or the database session management would handle that?
How does it enforce an authentication?
Yeah, we'll go over that. So quick, before we get into TCP injection, just a quick TCP overview. I'm sure most of you are familiar with the protocol. Quick refresher, the big things you need to know for TCP are the sequence and acknowledgement numbers, as well as the control flags that are set. The big ones being SYN to open up a connection, ACK or acknowledgement to acknowledge the fact that you received a packet, push to actually push your data out to the server, say, hey, this is your data, and then FIN to close out a connection. So I don't, it's really small again. So the way the sequence and acknowledgement numbers work, you send out a packet to a server with, say, let's say we have a sequence number of, I can't even read on my own screen, 1,000, and a packet, an arbitrary packet length. Let's call it X. So my next packet that I send out from the client to the server is going to have a sequence number of 1,000 plus X. When the client receives this packet, they're going to send out a acknowledgement packet, an ACK packet, with the acknowledgement number set to the sequence of the previous packet. Everybody with me? Cool. I'll take your silence as a yes. Really the biggest takeaway from this is that sequence numbers are predictable. They have to be. Sequence numbers are used to tell you, are used to control for out-of-sequence packets. So when not a web server, but a client is receiving something over the TCP protocol, it can say, hey, I got these packets out of order. It can rearrange them and it's good. Or it can say, hey, I got packets 1, 3, and 4. I'm missing 2. Send a request back to the client and say, hey, I need packet 2. It'll resend it and you're good to go. And this all happens at the TCP layer, so it's completely invisible to the application layer. So again, the biggest takeaway, sequence and acknowledgement numbers are predictable. They have to be, just because that's what they're used for. And there's no authenticity verification. There's nothing into the TCP protocol, or nothing built into the TCP protocol that gives you any kind of assurance of integrity or authenticity, which is great for us. So what happens if you put a packet on a wire with a valid sequence and acknowledgement number and a spoofed MAC and IP address? You get TCP injection. So what ends up happening, forgive my crappy MS Paint skills, by the way. I couldn't find a diagram for this on Google, so I had to make my own. So we have the first 2 packets that get sent out. The client sends a request to the DB server. The DB server responds. I, as an attacker, am passively watching this connection on the network, and I put a packet on the wire and spoof the IP and MAC address to make it look like it came from the client, put a valid sequence and acknowledgement number on it, send it out to the database server. And the database server, as far as it knows, just got another request from the client. The database server processes the request and kicks out its response back to the client. I am just sitting on the wire, and I just pick that response right off of it. It doesn't need to come back to me. I'm already sniffing traffic anyway. The problem with this is the client didn't actually send this packet out, so it doesn't know what the hell to do with it. All it knows is it just got an ACK for a packet it didn't send out, an acknowledgement to a packet it didn't send out, and it breaks the entire connection, because now you got packets out of order. And again, depending on what the client is, depends on how this gets handled. But we got what we wanted. We got to execute our one command. So for a quick demo on how this works, or how it looks, I should say. Again, I'm going to run this from my desktop. So again, SQL Viking on the left, our database on the right. We're going to run R to execute a query, and we're just going to select everything from the testdb.employees table and limit 1. Specify our IP to execute against and our port. Just a quick confirmation, and we get a nice little message that says query will be run as soon as possible. On the database side, we're going to run a couple queries, and I'll explain why we have to do that in a second. And after we run these 2 select queries, we get a message in SQL Viking that says, hey, we sent 1 packet. Great. So let's dump it on the wire and see what happens. Or I'm sorry, dump on the wire. Dump it to our file and see what it looks like. Oh, actually, really quick. So again, my SQL client freaks out. You can see the packet numbers on the left-hand side. That went from 4,500 to 5,500 to 6,000. This was a private network between me and my virtual machine. There is no other traffic getting sent over the wire right now. That is 2,000 packets of ACK, bad ACK packet, ACK, bad ACK packet, just pinging back and forth. Anyway, so we can see here, we actually got the response. We see the select star from testdb.employees limit 1. This wasn't run on the client. We ran select at version twice, and that was it. And yet, we get our response down here. You get me, Callahan John, john.callahan, gmail.com, certified application security specialist. Yeah, certified ass. I'm kind of bad at my job, so I am a badass. Just want to say that. Whoop. That's not right. Go back. I will say it acts kind of wonky. As you can see, I actually get the response 4 different times. You scroll down, if I scroll down a little bit more. You can see I'm getting the same response multiple times, even though no request is put on the wire. I thought it was a bug in my code, but I can find no reason for this to be happening, so I think it may actually be the SCAPI library that's freaking out. Again, still working through this. I'm not sure what's causing the problem. That very well, actually that, oh yeah, that may be it. Yeah, it doesn't see the response, so it's resending it back out. Do you have a question?
Are you running a separate monitor to test it, just a PCAP on another system?
Yeah, I did, and I only saw the packet come out once from the DB, but again, maybe I just need to look a little harder. So I'm not quite sure what the issue is. I've only spent about 30 minutes looking at it. Again, I just finished refactoring today, and it was only testing today. But you can see here, I tried to run the select at version again, and the client just hangs. And that's because now your sequence and acknowledgement numbers are out of sync between the client and server. So you have to kill it off and you have to restart. It's not going to gracefully recover from that at all.
So you're saying the client is confused, not the server? Correct.
The client is confused.
Okay.
The data, as far as the database is concerned, it's been receiving packets from the client nonstop. But since the client is not the one actually sending it, there's an off by one error between the two of them. So you could say both of them are confused, because I confused both of them. But the client is the one who's like, I don't know why you're sending me these packets with these numbers. I never sent you a sequence number 1300. The last one I sent you was 1150. I don't know why you're sending this to me.
So you should be able to send a quick connection reset right after?
Yeah, and that would be a good way to handle it from my side. If I just send a fin packet out and just force the connection closed, that'd probably be a better way to do it. But again, when I was originally testing it on a Windows environment, I wasn't having this issue. I wasn't getting 2,000 packets getting pinged back and forth between the two. It handled it much more gracefully. So really, it's just going to take a lot of testing.
Meaning that it just skipped right over and kept on going?
No, it recognized a bad packet got sent, so it sent out a fin packet, which closes the TCP connection, and it would just restart the connection, which is about as graceful as you can hope, according to protocol specifications. So it's really just going to be a matter of standing this up in a million different testing environments and seeing what happens when you're running on this kind of stack or that kind of stack.
Have you compared it at all with, say, a PHP client or a jar?
I have not. The only two I've messed with are the two SQL Server MySQL clients and a .NET app running it.
Interactive clients.
Yeah, yeah. Yeah, and even running .NET, I had, the first time I tested it, it handled it fine. The app did all right. The page would hang. You'd have to reload it, and you'd be fine. It would reconnect completely okay. The second time I tried it, like a month later, I rebuilt what I thought was the same app. And yet, when I injected on top of it, I started getting YSODs. I started getting error pages, yellow screens of death. I don't know what I did differently. For all I knew, I built the exact same app. It was just a simple test login page. It may have been I was using a different version of the ODBC for SQL Server. I may have been using MySQL instead of SQL Server. I don't really remember. But again, running a very similar .NET stack, two very different errors that happen, or handling of the errors, I should say. So again, it's really you're just going to have to stand it up and try it in pretty much every possible stack. Or just, pray for good luck. I hope the data you're pulling out, you got one shot. I hope the data you're pulling out is worth probably setting off every alarm around that you're on the network. Where did my slides go? Here we go. So some more Pillage fun. I had this idea a couple months ago when I was looking around at the way MySQL handles authentication, or it handles its handshake. Apparently, up until MySQL 4.1, I want to say, but pre 4.1, they used a handshake scheme called MySQL Old Password, and it is very, very, very broken. I have yet to find any write-ups on any technical explanations on how to exploit it, but if you Google that search, it's just 10,000 pages of what the hell are you doing, disable that immediately. So apparently it's broken. You could probably figure it out with a little bit of reverse engineering. However, I had this idea. Well, it turns out that even modern-day clients up until 5.7 still support this old-school authentication handshake. So what you can do is during the handshake, you can inject a packet on the wire, acting as the server, telling the client to encode their password using this MySQL Old Password authentication scheme. So it takes this password, weakly hashes it somehow, and puts it on the wire. Now the server is not going to be expecting it because the server put out a packet that said, hey, no, use this. So the login is going to fail, but you just got the username and the password pair. I can't remember. I built a POC for this and then I lost it. Somehow, in today's day and age, I managed to lose a piece of code. I don't know how I did that. And I can't remember exactly how it got handled from a client's perspective. I think it just hung, and then you just Control-C it and you could restart. So from a user perspective, it doesn't really look that fishy. But from attackers, I went from nothing to having the root password that the DBA is using to log in with. And now I can just log into the server and look like a legitimate user. The way it works is, so we got another PCAP here. So you have the first 3 packets, your client SYN, the server SYN-ACK, and the client ACK. So that's your TCP, your typical 3 packets that are sent during a TCP handshake initiation. So after that, the TCP connection is considered established and you're good to go. The first thing the server does is sends out a server greeting packet and basically tells the client, like, hey, use all these different settings, and the one we're interested in is use this protocol for encrypting your username and password before sending it back to me. Encrypting/encoding, or hashing/encoding, I should say. Client says, okay, great, sends all its information back to the server, authentication happens, if you're good to go, you get a connection established message, and you're good. So it's a bit of a race condition, but what you can do is if you're trying to attack this way, is you sit on the wire and or sit on the network and you watch for any SYN packets that got sent to a known MySQL server, and the second you see that SYN-ACK come from the client, you put that server greeting packet on the wire. It turns into a race condition because you have to put it on the wire before the server can. You have to get it there first. But if you're successful, dude, you're good. You're golden. You just stole credentials from a user and they don't even know it.
And you're using Scout to look for it.
Yep. So this would be implemented in Scout.
Right.
It would sit there and you enable it, and it would just sit there and watch for that packet. And then this is the response, the login request from the client to the server. I don't know if you can read this, but down here it says MySQL native password, which is the modern authentication scheme. But it also has root and then the password hash and salt following it. Again, I haven't built into capturing that yet, but still working on it. So anyway, after all that big doomsday talk, the fix, just encrypt your traffic. I mean, if you do that, you're golden. All my work is for naught. That said, don't fall into the same problems that every server admin seems to fall into. Please set up your TLS correctly. That means using a Diffie-Hellman key exchange to give yourself perfect forward secrecy. That means enable client and server verification, because unlike a web server, you know exactly who should be connecting to your database. You know that your DBAs are sitting on these 2 boxes, and your web server is sitting on those 6 web servers. Those are the only 8 things that should be connecting to your box, so it's very easy to distribute out a couple of keys and do client verification by the server. That just hardens you up even further. SQL Server 2016 comes encrypted by default, both at rest and in motion. I don't know if there's been any write-ups on exactly how that works yet, but I do plan on playing with it because I want to break it, because I'm kind of salty. I mean, excited that they implemented that. Also, quick mention to the backronym attack, if any of you guys have heard of it, came out a couple weeks ago for MySQL. It's essentially SSL strip for MySQL. So if you're man in the middle in a connection between a client and a server, when that server sends out that server greeting packet, one of the flags is use SSL. If you're man in the middling it, you can flip that bit and send it to the client, and even if the client specifies use SSL, it won't, which, why not, I guess. So you end up with an SSL strip scenario. You have unencrypted traffic between the client and the man in the middle, and then encrypted traffic between the man in the middle and the web server. That was fixed, thankfully, because that's pretty bad. But it wasn't backported to 5.7. I think only the latest version is currently not vulnerable, which is fantastic.
So just a quick question.
No problem.
2016 SQL Server encrypted by default at rest. What does it mean?
It means all your data is going to be encrypted on the hard drive. So if I was to dump your hard drive, I'd have the same issue if I was to dump a TrueCrypt archive. It's encrypted. I can't just read it. I can't just plug it in and pull the data off of it. I have to go through a decryption process.
The decryption key.
Yeah, exactly, unless you find the decryption key. Again, I haven't seen any technical write-ups on exactly how that works, but that's their big claim right now. To be released sometime this summer, at least the beta version. So future improvements, fingerprinting. I really want to put some time into this. It is kind of arbitrary because, again, as a penetration test, the first thing you should be doing is enumerating all the databases anyway. But at the same time, I think it's a pretty cool feature to have in case you find a database sitting on some really random port up in like the 50,000 range you would never look at anyway. And encryption support. So even though encryption is the solution to this problem, if your private key gets stolen, sucks to be you. So I would like to be able to pipe in a private key, and then it'll handle the decryption process for you. It'll look at all the encrypted traffic, decrypt it on the fly, and be able to do everything you could do otherwise, both Scout and Pillage. And of course, more databases. The only thing that's really even close to fully functional is MySQL. There's a little bit of SQL Server support, but not much right now. And I mean, there's a million databases out there, and it's just a matter of spending the time and parsing the protocol apart. That said, SQL Server doesn't work that well because the TDS scheme, tabular data stream that Microsoft wrote, didn't implement it correctly for SQL Server, which is fantastic. It is a pain to try and parse SQL Server traffic, a total pain. MySQL, on the other hand, is very simple. It makes total sense. A little bit on the directory breakdown. So you've got your, there's a lot here. The two big things are the SQL Viking.conf and the SQL Viking.py file. That's what handles all your big logic. And then inside the databases directory, you have your basedb.py class, which should extend or be extended by every database support class you write. The two in there right now being MySQL and SQL Server. And if you want to take a look at it, the repository is right here. My GitHub alias is Atticus, 2 S's, 2 C's, or 2 S's, 2 T's, SQL Viking.
So what's your overall objective? Is this something that you consider taking to an OWASP project? I mean,
I'm open to it. I have no real big plans for it right now. It started out as a kind of proof of concept, like, hey, I wonder if I could do this while I was at work one day and had some downtime. And then it kind of blew up into a whole big thing and just started adding features like, oh, I could do this, oh, I could do that. Turned into a much bigger project than I was originally anticipating.
yeah.
So yeah, feel free to fork it, pull it down, rewrite it. Judge me by all means because my code is terrible. Terrible. I spend all day judging developers and then forget how hard it is to write code.
More secure systems will keep you out of the back-end system. You mentioned DMZ. They use firewalls and they actually use routers to make sure the traffic is going between the web server and the database.
Exactly.
You could still inject, but you'd have to be on that back-end. And if they set up the firewall right and the system is set up right, they would keep you out.
Yep.
So that's what they would do in secure systems, but that doesn't always happen in the real world.
Exactly. All it takes is one tech support guy to pull down the malicious file that I'm asking him to do for me. So yeah, that's it. Any questions or anything? Comments, concerns? Cool.
All right, thanks.
Thanks for coming out, guys.